thanks everyone for joining for our spotlight about the Google Summer of Code, organized by the Open Source Community Citizens Network, but actually brought to us by Brian Gardner and his awesome students that we'll get to know today. So what's this all about? It's about the Google Summer of Code. In case, so let's take a first step back. What we're gonna do today. First, I'm going to give you a very brief introduction of what the Google Summer of Code is, so that we all know what this is about. Then we have three guests here. They are going to present their cool projects that they've been working on and are still working on. And then there's the opportunity for you to ask questions and get them to know better. So let's dive right into about the Google Summer of Code. In case you are not overly familiar with this, so this is a program that's been created by Google in 2005. Since then, it's essentially a program to get more people into open source. And so, what is this? So this is really an online program that should encourage new contributors and especially get people on board into the open source communities for the long haul, and provide them the opportunity and also the means to do so. It used to be restricted to just students, but since this year, actually anyone over 18 can participate, which is, in my opinion, pretty cool thing. So maybe instead of this high-level pitch, let's take a look at a few details. So this is really a global program. So this is not really restricted to just the US or like some other programs that just work in a single state. So anyone from all over the world can participate. As I said, since this year, it's really open for anyone who's 18 years or older. It used to be just university students, but this restriction got lifted. There can be medium-sized or large projects. So usually organizations will apply, and they have an idea what contributors could work on, and nowadays they can submit, as I said, some medium-sized or bigger projects. So those large projects that they really allow you to dive deep into something. Usually this is so, as the name suggests, Google Summer of Code, which tells you that this is a Northern Hemisphere kind of thing, because it's actually currently winter in the Southern Hemisphere. But that aside, it usually takes 2 weeks, but you can extend this to up to 22 weeks if you agree on this with your mentor from the mentoring organization. And a very, very great thing about this is actually that the contributors who work on this, they get paid by Google for doing this work, which is really a great opportunity, because if you are not from a relatively wealthy part of the world, i.e. Europe and North America, you usually don't have the time to do things like that in your free time. If you're not studying, you're working because you want to live when you study. So this is a great opportunity for people who are not so fortunate to be living in a wealthy part of the world. So goals of this program are, well, obviously you want to get new contributors. That's rather simple. But then also a plan of one of the ideas is also to really get new people on board for the long haul. So not to just essentially create code and throw it over the wall, as you would say figuratively, but get these people into the community that you have in your open source projects and keep them there. So, and also real world exposure. So if you're a student and you've worked on software, it's you work essentially on your tiny things, and you don't get exposed to all the additional details that go there, like communicating with people on mailing lists, participating in meetings, working on the actual testing side, getting stuff integrated in other projects, and. So I guess many of you have participated in some open source projects, or even if you haven't, you've probably worked with other people, and you know the discrepancy between how you thought software development or work in general worked when you were in university, and then how it's actually. So, well, and at last, the one of the more obvious goals is, well, create more open source, because when is that a bad thing, right? So how does this roughly work? Every year, first the projects apply. So one of them is, for instance, the openSUSE project, which sponsored these ones. The projects they have a rough idea what they want to do, so they apply with concrete projects. Then Google selects organizations, which has been roughly 200 in 2021. After these organizations have been selected, then the contributors who want to participate in the Google Summer of Code, they submit their proposals to these organizations. After that, the organizations that have submitted them, that have applied themselves and have been accepted, they select mentors and pick their participants. Well, and once all this pairing and all the paperwork has been done, you can begin with coding. So this year it worked roughly like this. So the organizations applied in February, which is usually the time frame. So in case you have a cool idea what you could do in the openSUSE projects, February usually Doug sends out an announcement that, hey, if you have an idea, submit it today, and that would be your time. Then Google selects them in roughly around March. Then in another month, the contributors submit their proposals. Then the whole thing is announced. Well, and then really, starting from June to September, people start coding on this. Well, and as you can also see on the slide, so essentially around this time, the first project should be finished, the short ones. And if you extended the period, you can code until November, which is a little bit of a stretch for summer. But then again, there's a southern hemisphere. So, well, a few statistics. So the Google Summer of Code started in 2005. There's been up to this day, there's been over 18,000 participants from 112 countries. So really a global thing. Also in total, over 17,000 mentors from 124 countries. 746 open source organizations have participated. So you had your really big ones like Mozilla, Google itself, openSUSE has been part of this, but also smaller ones like, for instance, Pigeon. Back then it used to be called Gaijin, I think. But so, and something like 40 million lines of code have been produced. So compare that to, I think currently the Linux kernel is something like 10 million lines of code. So it's quite a lot. And with that, I'd like to hand over to Brian, who will introduce us to this specific project.
Thank you very much, Dan. I appreciate that. And I'll try and move to the next slide. So what I did, and I wanted to do the Google Summer of Code for a long time. So I reached out to Douglas and said, hey, can I make a project proposal and whatnot? And that's what I did for this time, for the first time. And because I've worked in the open source world since the late 90s and worked with education and everything, I really wanted to move forward to this. So what I proposed, and this was based on things that I've been working on for multiple years about doing analytics or AI ML edge ecosystem workloads. And I proposed that out there, and that top colored text is a link to it if you want to get some more details on it. But what I wanted to do was get contributors, although I was thinking, I'm hoping I get one, but I got 3, and that was really awesome. But we wanted to create open source microservice workloads to do the analytics and to be able to deploy them wherever, whether that's where you train and test, like in the core of the cloud, or whether you actually run it the analytics at the edge. So we wanted to span that whole ecosystem with this. And then what I proposed is like 8 or so different industry verticals. And when the contributors came in, I basically said, you can pick whichever vertical you want, and let's make an example of this, and let's use open source tools throughout. So that's the project that I proposed. And again, we ended up with 3 contributors, and you're going to get to hear from these amazing gents. And what they did is they picked these 3 verticals to focus on: something in the finance space, something in the healthcare space, and a thing in the smart city space. And you'll see what those are. And with that, I'm going to turn it over to Abhinav to go through, and he's going to talk about the healthcare one first.
Okay, yeah, thank you, Brian. And first of all, thank you, everyone. And I'm really glad that I'm here. So let me start with my presentation. All right. So guys, I am Abhinav Sharma, and I am a Google Summer of Code contributors with openSUSE, and specifically, I'm working on the healthcare based vertical. And what I'm working upon, I'll show you in the soon in the next slides. Before that, I'm also the 14x certified in Azure, and I'm a GCP's professional cloud architect. And let us now jump to the project. So today's objective is my first, I'll introduce you to the project, what I have been working upon and what I have accomplished so far. Then I'll be giving you a brief introduction about the tech stack which I'm using within my project. And finally, I'll give you the application walkthrough, that what I have been doing so far and how it looks like, what it physically looks like, right? So first of all, the introduction to my project. So I have created a machine learning based cancer prediction workload. It's a edge core cloud workload. As Brian told you that we were working on the edge core cloud instances workloads. So I have chosen the healthcare vertical, and specifically I will be working on the cancer prediction model. So my application will be having 2 interfaces, and first one is for the lab technician, the one who receives the DICOM image. The DICOM is a spatial extension which we use for the medical based images. So one lab technician will have that image, they will do some modifications over that image, and once they are satisfied that yeah, the CT scan is right, then they will pass that image to the doctor. Then the doctor is the one who will analyze that the reports are right, which are generated by our machine learning model. And we also have a retraining self-training machine learning models, which states that whenever doctor is not satisfied with the results, right, they can send that images to the retrain, and then the retraining purpose will happen. And this complete application is a clusterized application which can be installed on the edge devices within the hospital premises. So now let me tell you the tool stacks which I'm using. The first one is the Kaggle. So Kaggle I have been using for data set. I have collected the data set from the Kaggle, and Kaggle is the one who don't know. So Kaggle is the world's one of the biggest, you can say, the collection of the published data, the open source published data, which we can use for the research, training, development purposes. Then for the machine learning, the libraries or the frameworks which I am using is scikit-learn, Keras, and TensorFlow. Then I am using convolutional neural network for the creating my cancer prediction model, and then the optimizers. Then I'm using Flask. Flask is actually a micro web framework which I've been using for creating my applications UI, as well as the integrating the machine learning with the backend. And of course, I'm using Rancher to manage my clusters, because complete application is clusterized, and Rancher make it easy for me for automated deployments, to manage the files, to manage the namespaces. And then I'm using Longhorn. So Longhorn is a Kubernetes. So I'm using Longhorn to attach it to my pods, the doctor app and the lab technician app, and where the retraining logic and my data will store is in the Longhorn. I'm using Longhorn for those purposes. And finally, Kubernetes cluster. So I have tested my application with various distributions of Kubernetes, either it is K3s, RKE, RKE2, K8s. My application works perfectly with all 3 distributions, 4 distributions. But for testing purposes, I've been using K3s because the installation is very minimal and it is easy to debug within the K3s clusters. And yeah, I'm also using Kubeflow as well. So Kubeflow is I'm using for retraining for the MLOps purposes, training my machine learning model whenever the doctor is not satisfied with the results. So this is the architecture diagram of my project. This is the current what I have built it so far. So here on the screen, you guys can see that I have a DICOM image. This DICOM image comes from the machines, the machineries, the CT scan machines. Now these model are fed to the lab technician app. Here my first model will identify that which body part is examined. So this is another machine learning model, my first model, which will examine whether it is the chest or abdomen or mind or which kind of CT scan it is. Now in this application, lab technician will adjust the contrast, the brightness, rotate the image, and then if he's satisfied, he can just push this image to the doctor with the use of PVC. So whenever any upload happens in the PVC, that will be displayed on the doctor's dashboard. And on that doctor's dashboard, I will be having a TensorFlow model. And this is my cancer prediction model, which will predict and generate a report that whether or not patient is suffering from a cancer or not. And if the doctor is satisfied from the result is generated. And if he is not, or she is not, then the model will be sent to the retraining purposes. For that, I have been using the Kubeflow retraining pipelines, which will use the image, retrain this, and send back again a new model for the further for the future process, right? And this is the content I have built so far. I have a GitHub repository with the name CT image scanning, and my username is Abhi Batra. And there I have been hosting this complete project, which is under development yet, but I'll soon going to complete it. Apart from that, I have written 4 blogs on Medium as well, and one on LinkedIn to actually document my every iteration, because with every iteration we got a chance to improve ourselves, and it is really an amazing part of our project that whenever we had a meeting, in week we have to be twice or thrice we meet with each other, and we used to discuss what we have done so far and what we are going to do in the future. So with those iterations I got to learn, and with every learnings I thought that I should create and mark my every step of GSoC under the blogs. So for those purposes I have written those blogs. With each and every step I have been incrementing and adding to my project. So now let me give you an application walkthrough. So yeah, this is the application which I've created. So this is my Rancher portal, and this is installed on top of my cluster, and the cluster is hosting this. Now inside this clusters, I have 2 nodes attached to it, and then I have services also. First, let me show you the namespaces. So these are the general namespaces for the Rancher. Then I am having the cancer namespace, in which I have been hosting my lab technician as well as doctor's app manifest files. And inside this you can see the deployments. And when I scroll down, yeah, you can see a Kubeflow. So Kubeflow namespace is used to host my my automation pipelines, which I've created for MLOps. And this is my Longhorn portal. Longhorn is also integrated within my project itself, and Rancher gives us an ability to have a UI, complete great UI with the Longhorn. And here you can see the dashboard of my Longhorn, which I have attached as a PVC, as a persistent volume, to my complete application. So now let me give you the glimpse to the dashboard which I have created for both the applications, right? So yeah, this is my lab technicians application, and this is the first UI, first application, which is hosted on 5002 port. So it has a logic as well inbuilt, which says that if you upload without an image, it throws an error. Apart from that, it accepts only the DICOM images. So what happens if you try to upload the image which is not a DICOM image? So let's say this is a picture of a beautiful cat, and if I try to upload this, it says that image type is only DICOM. So that is the another logic which I have taken care of. Then let us try to upload the actual DICOM image, the DCM image or the CT scan image of a patient. So when I upload this on the here on the portal, you can see a lab technician can adjust the brightness and contrast of the image. And here is the image which you can see as well. And they can also rotate the image as well as per their convenience, or what will be the best view of a image. If they satisfied, they can send the report to the doctor, which I've also shown you in the architecture diagram. Now the report is sent to a doctor. So let me take you to the doctor's dashboard. So here you can see the doctor's dashboard and these are the current open cases. So when I refresh it, you can see the latest image is also appeared here, right? So when I click on this image, doctor can see the prediction, what it predicts. So it predicts that this is a chest body part examined and the patient might be suffering from cancer. And this is the prediction results of our machine learning model. Now, let's say there's a doctor, Abhinav Sharma, and he says that, no, I examined that there is a case of pneumonia as well. So they put a label as a pneumonia. And when they click on the submit button, um, this will trigger my automation retraining, machine learning retraining pipelines. So within the Rancher, we can just open the retraining UI as well. So when I click on the Rancher's UI, here you can see my Kubeflow pipelines appear. Within the runs, I have my runs. So this is the run which is triggered when we added a new image for retraining. So this is a simple basic the tree or a graph which shows how the retraining works. So first step, the second, third, we can just simplify and check the graph, and then we can just download the data. So this step is responsible for downloading the data for retraining. Then the pre-processing data. In this step, we just pre-process the data because from the raw, we need to make our data usable by our machine learning model. So for that reason, we perform some use of NumPy and Pandas library for pre-processing. Then final step is the training model. We can just train the model over the pre-processed data which we acquired. And here as an artifact, you can see that we can either download the data as well. So when I click on this, you can see at the below that I am able to download my machine learning model, which I've created so far. And for the final step is for the prediction. So prediction is actually checking the model's validity over the validation set, because I've segregated my data into train, test, and validate. So this will test whether the prediction is right, and we can also check out the logs from the ML pipeline UI. And here the log which says that model is trained, and these are the precision and accuracy parameters of the various tests which are performed over validation test. So this is all about my model. This is all about my project which I have been building so far, and I have built so far of now as of now. So thank you. That's all from my end.
So welcome everyone. I am glad to be here and thanks everyone for joining the meeting. So my name is Naveen Chandra. I am from New Delhi. I'm a first year computer science student from Bharati Vidyapeeth College of Engineering, and I love to explore new software and open source software as well. So let's see a look on what we are going to discuss today. They are the points. So first of all, why I joined this project. So I was looking in the starting of this year, I was looking to start my open source journey, and like Google Summer of Code was the best way to get started in this field. I also had a keen interest in Kubernetes and Docker concepts. So I like I like this SUSE organization and its Rancher project. So I joined that. So let me give an introduction to the project. Analytics Edge ecosystem workloads. Basically, we need to create an open source based microservice workload spanning edge to core to cloud infrastructure. And I choose the finance vertical because I am like very much interested in that vertical, and I have been working on it for the last 2 years as well in the stock market as well. So I created a machine learning based application which with different financial features that can be deployed on the Kubernetes cluster. So let's have a look on what I have learned so far. So this GSoC experience has been a really good for me. In just a couple of months, I got to know a lot of new things. Our mentors are great. They just give us a well-defined task list in the community warning period so we can get acquainted to the acquainted and get familiarized to the SUSE products and services. Here are some of the services and products I got to know about. Rancher. Rancher is a K8s cluster management tool. I used it and it has some amazing features like Fleet, which we can use to deploy a set of manifest files automatically on a lot of clusters. And Longhorn also, it's a storage class. And after that, we have three different distributions of Kubernetes, K3's Archie, RQ2. I personally deployed a 3 VM node cluster and imported into Rancher. MLOps. So I learned how to create machine learning models on Kubernetes cluster, containerize them using Dockerfile, and also use Kustomize to deploy them. DataOps, I created some machine learning pipelines to automate train test data and cleans them. I used Kubeflow and MLflow for the process. DevOps, I created some web user interfaces for users to see the stock market predictions along with other features. So let me just present my project that's predicting financial markets using machine learning. So basically we have a web app that can show future predictions of any stock or index also to the users. And we can get both long-term and short-term predictions for the user. The app will basically detect the user's location and show them predictions relevant to their location. We also have some ML model predictions which we can compare with the analyst recommended price to see our model is doing good or not. And we can also see for diversification purposes the stock market of other countries as well so that we can plan a better investment plan. And we also have sentiment analysis. So basically the stock market is varied a lot by the news headlines and their impact is significant than any of the other factors. So I created a sentiment analysis for stocks wherein we can basically see whether the news has a positive or a negative impact to the stock market. So here are some of the tech stacks and libraries I used for the project. I used Python for the backend. For frontend, I used Streamlit and Flask. For the research data modeling, I use Jupyter Notebooks. It's a really great tool and interactive way to get to see our and visualize our data processing. For ML models, I used LSTM and Facebook Profit. It's also open source. For sentiment analysis, I used Vader. For stock and index data, I used Yahoo Finance. It basically has a lot of data for more than previous 20 years, and we can get all the data which we require for the project. For model tracking, I used MLflow and Kubeflow. For deployment, I used Rancher, K3, Skates, and Fleet. Some other libraries are Pandas, GNews for the news, and Plotly for graph visualization. So here is my project demo. So basically it automatically detects your location based. So mine is India, but we can also select some other country as well. And then we can select short term or long term. And then we can also specify the number of days we want to predict for. And then click submit. And then we can expand this tab to get the predictions for like top 5 currently reported stocks, which are like famous. So here is for Apple Inc. This is for Google. It shows that it will go down 4.66% in the coming days. This is for Tesla. It shows it's gonna go up a little bit. This is Microsoft Corporation. It shows a negative trend for the coming few days. This is the United Health Group Incorporated, pretty much flat. We can shift the time frame to long term and predict for even more years. And with the predictions for the same stocks. So this shows a pretty much good uptrend and an annual return of 21%. So that's a nice uptrend going on for the next 1 year. This is for Alphabet, Google. It also shows a good upward trend. This is for Tesla. And this is for Microsoft Corporation. So yeah, most of them have good uptrend. This one has some significant uptrend going on. That was the first part of the project. The next part is that we can, if you want to get stock recommendation and view the predictions for any of the stock ticker, we can just input in the below block and select long term and short term from there. In this, we also get 2 columns here. First is the model predicted price, which shows 197, that is up 21% for the next 1 year. And we also have the analyst predicted price, which I sourced from Yahoo Finance, which shows a target price of 184 after 1 year. So that's basically $13 less than my predicted price. So yeah, we can see that the trend is good. The trend in both of them are predicted nicely. And then we can also select short term and specify the number of days we want to predict. So in the short term, we see that the stock movement is heavily based on the news also. We can sort it according to dates and view the stock market news and their sentiment score. A negative sentiment score signifies that the stock should move down. We also have a visual graph here so that we can visually see and get predict that what will the price go, like whether it's up or down. And here's the predicted graph for Apple IMC. That was for the next one is like getting predictions for other countries' stock market as well. We all want to diversify our portfolio and like we want to invest in some foreign exchanges as well. So my current location is India, so it will show me the relevant options for me. First with the USA stock market, it's like a little bit flat going on. And then we have the Germany stock market. It shows a little bit of negative downtrend for the next year. The next one is the UK stock market, the FTSE. It shows a good uptrend for the next year. The China stock market, that's not a very good sign. It's going a lot of down. Next is the Japan stock market, which we can see is also having a negative trend. So I deployed this workload on my Rancher server, which was provided to us by our mentors. Here we can see the pods running and also the services are up and running. We can basically go to service and access the application from here as well. So yeah, that was for my project demo. I have hosted all my coding in this GitHub repo, Naveen772 GSoC stock prediction. You can check that out and even clone that and run the application on your local system. I also regularly post some Medium blogs on my Medium at the rate NaveenChandra772. I posted 3 blogs covering some of the work I have done in this GSoC period. And I also plan to post some more blogs in the coming few weeks. So yeah, do check that out. Thank you, everyone. Have a nice day. For any questions, you can ask.
So hello everyone, my name is Akshit Jain and I am currently in 4th year of my college. I am passionate in machine learning and DevOps and love to collaborate on open source projects. So why I joined this project, like I have interest in machine learning and DevOps, and I also previously did some contributions on openSUSE organization. And like before GSoC starts, like I have the aim to collaborate to one of the projects, and I am working as an open source contributor at openSUSE organization. So I decided to go with their open source project, and I found Rancher, which sounds interesting to me, and so I decided to go with that project. So introduction to my project, like I am creating a traffic forecasting app. It comes under smart vertical and it has 2 interfaces. First is consumer interface and second is admin interface. So in consumer interface, like a consumer can enter the date and time when they want to go or they plan their commute, and they can predict or they can see their traffic forecast for that particular time, and they can plan their trips according to that. And in admin interface, like I provide live stream to the DOT, Department of Transportation, and they can they can send message to consumer side, like there is a traffic flow, or they can send alert notifications at consumer level, or they can use that videos to train their model again and again. So let me show you. So first of all, what I learned so far, like as an ML machine learning practitioner, I learned about how to solve real world use cases, how to approach a machine learning problem, and how to work upon a data set. As a DevOps practitioner, I worked with the Rancher. So Rancher is a Kubernetes cluster management and monitoring tool, and K3s, RK, and RK2 are like the versions of Kubernetes, and where K3s is lightweight version of Kubernetes, which is used in edge devices uh, for less computation. Like as a task, previously I also created a 3 VM node cluster and deployed WordPress server over it, and I used Longhorn as a PVC for that web server, a WordPress server, and I integrated Longhorn with that. As an MLOps practitioner, what I learned is like how to containerize your machine learning app, and how to like deploy it. And as a DevOps, I implemented Kubeflow and MLflow on my project. So tech stack which I use is like language Python. I use Python language, and in front end I use HTML, JavaScript, and CSS. In backend I use Flask, uh, and for research and data modeling, like I use Jupyter Notebook. My ML model is GRE, Gated Recurrent Unit, and you can learn all about all this stuff. I added link to this, which I preferred or I followed while making my project. So let me show you my consumer UI. So yeah, this is my consumer UI. Like in this, you can see I have graph, and I am going to implement a good graph. Like I'm working on a graph, and like as I am entering the date 31 August 2022 and time 9, it is at night, so it will predict and give me traffic according to that time. So like if predicted number is 3, the conditions are normal, and the time at which I am predicting is like late at night, so it is low, showing low. So yeah, this is consumer UI, it is low. Like this is my admin UI, and in admin UI, I created a login page, so that admin can log in into that, and I start the camera so it can live stream on the road, and they can like only set up the camera or they start recording their video. Like camera can be set up on the road to predict the traffic, and after that start recording. Like we can record it for any road, and it is like in Jaipur, so I am currently in Jaipur, so it is downloading for Trunk Road on Jaipur. So this is my vehicle counter. So like they have downloaded a video, so what they can do with that video is like they can apply vehicle counter on that, which I made, and like this is the code which I implemented so that they can track the traffic and get a CSV file from that. Like there is traffic on the road, so it is counting the car numbers, and it is like doing the making a CSV file from that traffic load, so that we can use this traffic CSV file to retrain our model for the particular city code. Like I use Trunk Road, and there are other roads as well, so we can do this stuff for every single road in the city. So like this is like it is making CSV file. After that, I deployed all my work over Rancher. I created a particular namespace for that. First of all, let me go into create here. Yeah. So in that, I gone into project namespaces here, and like I created a smart vertical space namespace, and like let me explore my cluster. So yeah, like these are my deployments. So I have deployed this, and I have 5 pods running, and I have created a service from where I can access my application. So yeah, like I can access my application from this deployment site on the MC. So this is my GitHub repo. You can visit it. Like I am updating the README file in it, and that's all from my side. Thank you.
Brian, the stage is yours.
Thank you. Thank you very much, Dan, and awesome job, Abhinav, Naveen, Akshat. I smile from ear to ear whenever we have these sessions and whatnot. And it was funny when I proposed this project, I was thinking, well, we're just going to focus on the ML ops thing with something like this. And we were just going to do that piece of it. And then every time we had our sprint calls, we brainstormed as a team and all tried to learn things more and more. So again, and for some reason, Dan, I can't, there, I got control now, or at least I'm requesting it. So we did the ML ops stuff. And then the next phase was, okay, because they wanted to learn about Rancher and stuff, I gave them a sample cluster, and then I gave them a bare metal machine, and I said, now you set up your own clusters, learn how to do that too, and then deploy workloads on it. And then I gave them access to a bigger cluster so that they could try, and as you saw on like Akshat's last thing, that was an older version of Rancher running, so that they had to figure out, make sure that it was available and do things for everything in the IT ops space. And then they learned about the data ops too, of okay, where did that data set come from? What do I need to do? How do I need to cleanse it, ingest it, do the right thing with it? And then they did the DevOps thing even above that to create those web interfaces for the actual users that are using that machine learning model, wherever it's coming from, to get the analytics answer that's dealing with the data and whatnot. So as you can see, this has been really, really fun. And I wanted to say some thank yous. Of course, the Google Summer Code, awesome. And then Douglas, thank you for sponsoring this project through openSUSE and whatnot for the Google Summer Code. And then I wanted to bring up another fact too, that I'm not the only mentor. Because we had 3 contributors, I brought in some other folks to mentor, Ann Davis, who's on the call, and also Brian Frome. And again, those contributors, they have done an awesome job. And even the plan that I had created at the beginning, halfway through the life cycle of the Google Summer of Code, they'd completed all that. So we were iterating over and over to go, how can we go farther? How can we do the classic open source, scratch the next itch? So with that, Dan, I'll hand it back to you, and maybe we can get some questions.
Thanks. So with that, yeah, thanks everyone. Thanks you guys. These have been really, really, really cool projects. So with that, we have still a little bit of time for questions. So so feel free in case anyone has any questions, just unmute yourself and ask. And if not, I have also things to ask. So
no questions for me. I just wanted to thank Brian, and Ann, and thank Navin, Akash, and Abhinav. You guys, I'm impressed, almost speechless. So thank you guys so much. It was very impressive.
Thanks, Patrick. Let me maybe ask a question for Abhinav. So you mentioned that your application, you have two prediction steps. First, you guess the body part, and then you then you try to predict whether there's some cancer going on. So I'm curious, why do you have this body part prediction in there? Because I mean, if I take a CT scan of a patient, I know which part I CT scanned, right? At least in my naive understanding. I'm not a medical practitioner by any means, so I'm just curious, why did you include this step?
Yeah, actually, like, thank you, Dan, for asking that. The reason behind taking that is actually my model is working on the CT scan images of the abdomen and the chest area. But let's say a doctor actually, why we talk about the lab technician. So in the healthcare space, we have to be very precise while doing any predictions, because it is very much you can say very sensitive or very confidential area. So for that reason, my model, my cancer prediction model currently supports only the chest, because chest cancers. So anyhow, let's say any patient come, they just do some cancer reports on some other body parts, right? There can be cancer on the breast as well. So as a lab technician, what I will think that I will pass through this model and pass the report to the doctor, right? So for his purposes, the report, the image will be sent to the doctor correctly, right? But my model is not ready to perform the predictions over the breast cancer, because that is only for the chest cancer as of now. So to be very precise before predicting whether or not it is a cancer case, like for that reason, I have put as for an acknowledgement purpose as well, that yeah, this is the body part examined though, right? So this is the reason behind the intuition behind keeping that model as well.
So do I understand it correctly? It's essentially for double checking. So you,
yeah, exactly.
okay.
It is for double checking and ensuring that yeah, this is the body part examined. And if you are not mistaken, I will also tell you, like as a lab tech, as an application, I will tell to the lab technician that this is for the double checking purposes. Yeah.
Okay, that makes sense. Thanks. And we have a question from Doug.
Yeah, can you hear me now?
Yes,
yeah, it's
loud and clear.
Thanks. It's for Navin. I'm just kind of curious, like, do you have any aspirations to go into sort of like hedge funds or any sort of financial market? I found your presentation very interesting, and could also see other areas that it could be used in.
Like, what's your question about hedge funds? I didn't get that.
Hedge funds or in the financial, do you plan on moving toward the financial markets and possibly expanding upon your talents that you have with this to yeah, just kind of help, I don't know, create companies that might go into investing in certain stocks or bonds or whatever commodities?
Yeah,
I'm just
that
curious.
sounds interesting. I'm up for that.
Okay.
Yeah, and just to go on from that, Douglas, too, one of the things that we're going to do next, besides write a solution stack, document on what all they did, I was going to reach out to somebody like a finance person in the investment phase and show them this stuff and get their feedback on it for Naveen to maybe do something else or give other ideas like you just came up with.
Well, we could
I have a
definitely
small
talk.
follow-up on this. So Naveen, you showed really cool graphs there, which showed some nice predictions. Have you run your model with past data to see how accurate it is? Because I want to know if I should buy stocks from United Healthcare. What was the name? Just asking for a friend,
Yeah, I trained the model on the past data, but I have compared the LSTM and the Facebook profit models and found that the Facebook profit models were a little bit more accurate than the LSTM models. So yeah, that's why I used FB profit for my predictions.
No, but I meant have you run a check against the actual evolution? So have you tried, I don't know, run the model a week ago and see what it predicted, and then compare it to the actual evolution that's happened?
That was interesting, and I did that couple of times. We can see that some previous weeks, the market was going a lot down. If you follow the stock market, it was going a lot in the red, and before that my model predicted that it would go down. So yeah, it works most of the time.
Nice. So if you plan on writing additional blog posts, which I hope, then please also include some of this analysis, because I'm certain if you want to get users and they see that your model is actually pretty accurate, that's a selling point. And selling point, I mean, in this sense, it's quite literal. So
yeah, I will take that as a note and include the analysis part even in my blogs. Thanks for the suggestion.
Okay, and I also have a kind of similar question for Akshat. Since you have done also predictions of the traffic, have you tried double checking how your predictions, whether they are accurate with actual traffic data? I don't know if you have access to traffic data, but I know Google has, probably by stalking everyone's cell phone, pretty accurate traffic data out there. Have you checked it, how it's whether it predicts stuff correctly?
So yeah, like this data set is a private data set which I found on GitHub. So yeah, I splitted the data in training and testing, and after training my model on that data, like I also tested it with like the testing data, and I found that the results are pretty accurate. Like 2 or 3 vehicles count are less, but yeah, the traffic data accuracy is very good.
That's cool. So if you I don't know, should be bored at some point, then please find out how I can get this stuff in here, and how I can find out which route I should take or which bus I should take to actually get there and not get stuck in some stupid traffic jam. I'd love to have that.
Yeah, like that's the whole motto of that consumer UI. Like for I I tried to make this app so that like consumer side, they can't get stuck into the traffic. Like they can get predictions for their road. So like I am currently in Jaipur city, so it will go through all the roads, and like we can fit camera on all the roads and get data from every road. And like after that we can train model on different roads and predict for different roads, and we can share them with the users, so that like if they want to go on a particular road and they are planning to go for a trip, they can't face any traffic issues, or they can change their path if there is any traffic on that road in 1 or 2 hours, or like tomorrow. Yeah, that's a
Nice. So is this are you planning to include some kind of collaborative effort? So essentially that you have a community of users and everyone just puts a webcam on outside in the window, and if they're living next to a busy street, and you'll all collect the data somewhere.
Yeah, like that would be a great idea, and that's yeah, like they can do, but like they can it can also be done by Department of Transportation. Like they can have better access or better view, so that they can fit on the highway, and they can like make a great video for a particular road. Like from a user point of view, or as a open source tool, people can't able to give me a proper view of that road, but Department of Transportation may give me a proper view of a particular road, so that it would be good for me to traffic count or to count vehicles.
Okay, thanks. Any more questions? Doesn't look like it. So with that, I'd like to thank you all for your attention. Thanks all for your time. Thank you, Brian and Anne, for sponsoring. Thank you, especially Abhinav, Akshat, and Naveen for showing this stuff to us. So this is all very impressive stuff. I wish you the best of luck in the future, and please please keep us posted about additional updates. And thanks you all. Have a nice day and see ya.